Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. Yes guys, we are still doing the mathematics paper 1 examination, which is a mid-year examination which was written in the province of Gauteng in the year of 2024. So please do expect a total number of 10 videos, since the question paper had 10 questions in total. And guys, it's very important for you to know how to tackle exam questions. I strongly believe it will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. Okay, the seventh question, guys, over here I think they were too lenient for you, or maybe it's because by June you guys haven't done financial mathematics, né? But this financial mathematics is just grade 11 stuff. Okay, question number 1. We are told that an investment earns interest at a rate of 7.5% per annum, compounded quarterly. Calculate the effective annual interest rate of this investment. We are given a nominal interest. We are supposed to convert it into effective interest. There is an equation for that, guys, and please do remember this one because it's not given at the back of your question paper. Let me check. Is it given? Is it given? Yes or no? No, it's not given. It's not given. So guys, please make sure that you don't forget this one, né? Please make sure you don't forget it because it's not given. So the equation for you to convert effective interest to nominal interest or vice versa, it simply says 1 plus I effective is equal to 1 plus I nominal all over m to the power of m. Né? These m's, they represent the number of compoundings. Okay, I simply have 1 plus I effective is equal to 1 plus, I'm given the nominal interest as 7.5%. Né? I'll simply divide it by 100. This will be 0.075 all over. It's compounded quarterly, so all over 4, and then all raised to the power 4. So therefore the effective interest, and please guys, do note that your effective interest should always be greater than your nominal interest. If ever you're converting the two and then you find that your effective interest is less than your nominal interest, there's something wrong that you did, né? So I have 1 plus 0.075 over 4, all raised to the power 4 minus 1. So my I effective will simply be open brackets 1 plus 0.075 divided by 4 all raised to the power 4 minus 1. This is just 0.07713586578. Are you together? And therefore, for me to find the rate, the annual effective rate, I just need to multiply my effective interest by 100. Are you together? So I'll simply say multiply by 100. This will simply give me 7.71%. So you can see that, guys, my effective interest rate is slightly greater than my nominal interest rate. And it should be like that, guys, always the case, né? That's 7.71%. Okay, and then I'm told that rhino poaching is a serious problem and has resulted in the black rhino becoming an endangered species. Statistics shows that there were 60,000 black rhinos in 1970 and only 4,200 remain in 2011. Determine the annual rate of population decrease as a percentage over these 42 years if the rate is compounded decay. Please guys, do treat this type of scenario as if you are dealing with an amount of or rather an asset. Are you together? An asset that has a value that depreciates over time. Please deal with it like that. Sometimes you'll be given a population of human beings. You must deal with it like you're having an asset which depreciates over time. So the depreciation, guys, is a compounded decay. So I'll simply have my reducing balance method. Okay. Presently I have 4,200 black rhinos, but initially there were 60,000 of them. Let me confirm that I read correctly. Yeah, there were 60,000 of them. I do not know their rates of decrease kutubani, but I know that N is basically 2011 minus 1970. So this amount of decrease just took 41 years. So I can divide both sides by 60. I'll simply have 4,200 divided by 60,000. That's equal to 1 to the power 41. I can take the 41st root. 41, 4,200 all over 60,000 is equal to 1 minus I. Therefore, I is just 1 minus the 41st root of 4,200 divided by 60k. Let me punch my precious calculator and see what I get. 1 minus the 41st root of 4,200 divided by 60,000. This will simply give me 0.0628, etc. And therefore, when I multiply by 100, I'll simply get to 6.28%. So the rate of decay is basically 6.28% annually. Yeah, it's 6.28%. Okay, now I'm told that Adam inherits 27,000, which he invests in a savings account. The interest is calculated at 4.5% compounded monthly for the full period. 3 years after he invested the initial amount, he withdraws X amount of rands to make a down payment on a car. Calculate the value of X if he accumulates a total of 17,614 rand 76 cents in the savings account after 10 years. Okay, it's very important, guys, to draw your timeline. It's very important. We have T is equal to 0 and then T is equal to 10. Over here we have T is equal to 3. This person invests 27,000 and in future he has 17,614 rands 76 cents. Are you together? But over here he withdrew a certain amount of money. Are you together? And the rate of interest is the same for the entire financial period. That's 5.4% compounded monthly. If it's compounded monthly, guys, please note that M is equal to 12. Okay. There is an easy way, guys, to calculate this thing. Now you can simply say A is basically equals to P 1 minus I to the n. Just take the 27,000 1 plus 0.054 all over 12. That's 12 times 10. Remember that, guys, you must always multiply your number of years with the number of compoundings to get the exponent over there, ne? Minus this amount of money which was withdrawn, but we'll take it as if we have wrongfully earned interest for the amount of money that you have withdrawn. So we'll say x multiplied by 1 plus 0.054 all over 12, all raised to the power, there's 7 years remaining, right? That's 7 times 12. So this will simply give me the value of x, and I know that the amount of money I'll end up having is just 17,614 76 cents. So for me to find x, I must just isolate this bracket over there, ne? So I'll simply have 17,000. Let me take the x to the other side. It will be positive x with its brackets, which is 1 0.054 all over 12, all raised to the power 7 times 12, which is 84, is equal to 17,614 rands 76 cents minus, or rather plus, or let me write it like this. I have 27,000 1 plus 0.054 over 12 to the power of 120 plus 17,614.76. All I've done, guys, was to take this amount of money to the other side. The x will become positive now, and then if I take this amount of money to the other side, it will be negative. That's why I end up having this equation over there. Are you together? Then for me to isolate x, I need to say x is equal to 27,000 1 plus 0.054 all over 12, all raised to the power 120 minus 17,614 rand 76, all divided by 1 plus 0.054 over 12, all raised to the power 84. This will simply give me the value of x. This will simply give me the value of x. I have 27,000 multiplied by 1 plus 0.054 all over 12, all raised to the power 120 minus 17,614 and 76 cents all over 1 plus 0.054 divided by 12, and then all raised to the power 84. All raised to the power 84. I'll simply get an answer of 19,656. 19,656 rands 28 cents. Okay, the first thing I did, guys, was to simply use my equation. Since I have nominal interest, I'm going to use a compound interest equation. Yeah? I'm told that in future the total accumulated amount will be 17,614, but there are things that occurred in between. Are you together? So I'll just take the 27,000 multiplied by the interest and then subtract the money that I've withdrawn. but I'll also subtract the interest it gained by mistake as well. And then this is the money I've withdrawn with its interest together, and then this is the 27,000 with its interest, and then all I had to do was to isolate this X over there, and then the rest was just algebra. And then the final answer is just 19,656.28. That's how, guys, we're supposed to deal with this calculation over there. Please do stay tuned and wait for more videos.